Okay, so check this one out. Now I am doing the opposite, right? So I am given the area, and I want, in this case, the IQ score. Look how X is here instead of Z. X represents a data value. In this case, my data value that is represented is an IQ score. So these again are IQ scores. So everything along the horizontal scale is an IQ score for both of these questions, right? Both of these examples. The mean is 100, the standard deviation is 15, mu is 100, the standard deviation is 15. And you know what this says, find the indicated IQ score rounded to the nearest whole number. So they're telling me how to round. They're giving me the picture. I don't always have a picture, but that's okay. We can draw that. They're not very difficult to draw. What this is saying is, what IQ score has 99.18% of the other IQ scores below it? Or what is this value here that has 0.9918 as the area to the left of it? So, or what IQ score has 99.18% of other IQ scores below it? So I'm given area and I want to know a value. So inverse norm is what I use in those scenarios. Inverse norm. I'm using the graphing calculator. Now, my graphing calculator that I have is a TI-84. Some of you have 83s and such. Regardless, I'm going to go with the area to the left. Okay, so this is how you are inputting your stuff. The first thing that you want to input after inverse norm is the area, the amount of area to the left of the value that you want, and then your mean and your standard deviation depending on what that is. So if I want to find this particular data value, this particular IQ score, the area to the left of it is given as 0.9918. The mean is 100 and the standard deviation is 15. So this is what it's going to look like after I input my stuff. Now, second bars, when I go to inverse norm here, you know, this particular calculator has this option and not every calculator does. So I'm just going to keep it as left because if you don't have this option, it's already area to the left, okay? So it's always going to be area to the left. This one directly gives me the area to the left as 0.9918. So that's easy. It's directly given to me. Input it. The mean for this situation is 100. The standard deviation is 15, right? When I paste it, right, this is what it looks like. Inverse norm, 0.9918, 115. Here mine says left. Those of you that don't have this calculator, it doesn't say that part, but it automatically assumes that. Enter. 135.99. We're rounding to the nearest whole number, 136. So the IQ score, 136. The IQ score that has approximately 99.18% of other IQ scores below it is 136. I would say that that's a very high IQ score based on the fact that 99.18% of adults are lower than that. This is an IQ score that has 15.87% of the other IQ scores above it. So again, I'm looking for a data value in this case. I'm given a percentage or a probability. The thing that I want you to be very careful with though is, remember that I said the area that I'm inputting is always the area to the left of the value that I want. And in this case, I do not know this area to the left. I know that the total area under the curve is 1. So I can say 1 minus 0.1587 would be this area to the left. Take the whole thing 1 and subtract this amount and I get what's left. I can straight up just plug that into my calculator without, doing it, before that. And then it'll give me the value that I want. Inverse norm. Inverse norm, 1 minus 0.15 something. 0.1587. The mean was 100, the standard deviation was 15. Always area to the left. Paste, this is what it looks like. If you don't have this calculator, it doesn't have this part. Enter. So rounding to the nearest whole number, 115. So the IQ score that, 115. The IQ score that has 15.87% of the other IQ scores above it is 115. So inverse norm is when you're given area and you want a value. If your area that is given is to the right of the value that you want to do 1 minus that number when you do inverse norm.